Okay. Good morning, good afternoon, good evening to you wherever you are. My name is Erin Wozni. I am the Business Development Manager here at Softree. So first off, thank you for taking some time today to join us for our webinar. So we're going to be focusing our talk today on the use of satellite DEM data for preliminary design, costing, and feasibility of roads and corridors using our road design software, RoadEng. Now, over the last few months, we have done a series of webinars talking about different data types. And we're actually covering one today that we've never even really spoken about because historically it's been associated with really poor resolution coarse data. And that certainly is not the case anymore. Satellite DEM data is something you wouldn't have typically used for a civil engineering project. And I'm excited to share that through our partners at AW3D, we think it definitely is. So I've got 3 different panelists with us here today that are going to be co-presenting. We've got Tepe Kato from AW3D joining us from Tokyo, Japan. We have Darryl Mack from Cambria Geosciences joining us from Kelowna, BC, and he represents a really unique perspective, which is a combined user perspective for both RoadEng as well as AW3D Data. And then we have our own resident webinar expert and our training manager, Matthew Dickey. He's joining us from the East Coast of Canada. Quick bit of housekeeping before we get started. First off, everyone here in the webinar is muted. You can engage with us though throughout the webinar using the Q&A section of your GoToWebinar panel. So you can just expand that out, type in a question. You are confidential when you ask it, so feel free to ask away. We will address those at the end of the presentation. So we have a pretty action-packed webinar over the next 30 minutes. Let me just advance this here. So our agenda, we're going to start with a technical introduction to satellite DEM data, where it comes from, how accurate it is, different uses of it. Then we're going to move over into a Q&A discussion to get the end user perspective with Darryl, and then finally pass it along to Matt for a live demonstration of working with AW3D data inside of RoadEng. And then we'll end likely in a bit of overtime. I'm sorry if we go over with those questions from you, the webinar audience. So with that, I did want to formally introduce Tepe. He is in charge of global sales and marketing for AW3D and NTT Data, and he helps clients to acquire the appropriate data for their projects. So welcome, Tepe, and good morning to you in Tokyo.
Hi. Thank you, Erin. Thank you for having me here today. Thank you, everyone, for joining us today. It's 6 a.m. here in Tokyo, the other side of the earth. It is amazing, and I really appreciate technology that makes this global collaboration happen. My name is Teppei Kato, or AW3D Sales and Marketing Manager at NTT Data Corporation, headquartered in Tokyo, Japan. I help clients who need geodata to accelerate their business in more effective and speedy way. My presentation is about AW3D, our 3D product derived from satellite imagery. I sincerely hope that everyone in the audience learn AW3D and how it can help your business for civil engineering projects. Here's the agenda. I have only 2 items. The first, the overview of AW3D. What is AW3D and the advantage of it? Second, how it is helping civil engineering projects. So let's get right down to it. We take advantage of 2 rapidly evolving technologies. The first, space technology. Imagine there were only a few satellites in orbit in the past, but it has dramatically increased in recent years. And now you have thousands of satellites in space, which means you have countless eyes to understand the Earth 24 hours. The advancement of digital technology is key as well. we've seen exponential improvement of computer technologies such as CPU, storage, and network. It enables digital technologies such as big data and artificial intelligence. Using these technologies, our mission is to digitalize the shape, features, and events on the Earth to help our clients get a better understanding of the Earth to accelerate their business and create better and healthier society. So what is AW3D? AW3D is products of joint business between Restec, most renowned remote sensing organization in Japan, and NTT Data, digital tech giant headquartered here in Tokyo. AW3D is not satellite imagery itself. We work with satellite companies and use their satellite imagery and process it with our cutting-edge technology, and create value-added products such as digital elevation model, 3D vector, change information, and more. You're seeing sample images in the bottom of the slide. There are traditional ways to acquire geodata: ground survey, aerial photo, drone, and cards. But sometimes these methods have limitations. You cannot fly your drone or planes over no-fly zone. You need roads to drive cars and cannot get data if the area is far from roads. Getting data beyond the borders are challenging, especially in this era with COVID-19, because traveling is not easy and not safe. Cost and delivery time is pain point for these methods as well. But now you have space, satellite constellation, as a new way of getting geodata. Satellite sensor can capture data for wide area without area limitation. You don't need to travel around, or you don't need to fly drone or planes. You only need to place orders for geodata for anywhere in the world. In addition, you can get consistent data easily. If you try to get geodata in several methods and combine them for simulation or calculation, the data tend to be inconsistent and the end result can be meaningless. But you can get consistent data with the same quality globally with satellite imagery. The freshness of data is another advantage of a satellite. Since satellites keep taking pictures and stack the data, you can get new data easily. Time series analysis is possible as well using archived data. You still may not believe that it is useful for your business in a practical manner. However, we already have global footprints in more than 130 countries and in more than 2,000 projects for many applications, from 5G simulation to, of course, civil engineering. It proves that satellite-derived data has become practical use cases, and now it is worth considering it for everyone. Your question would be how it can help professionals in civil engineering. I'm going to explain it from now. Geospatial information is widely used in civil engineering industry already. Site selection, construction planning, simulation, and more. What can AW3D add value on it? You can get high accuracy and high resolution geodata from home for wide area with low cost. That's the value we add to the market. We have several products used in civil engineering. From left to right, the first, AW3D standard. AW3D standard is DEM, DEM, digital elevation model, including DSM, digital surface model, and DTM, digital terrain model. We use JAXA's satellite imagery. JAXA is Japanese NASA. The resolution of the AW3D standard is 2.5 meter or 5 meter, and we have off-the-shelf digital elevation model for the entire globe. One of the typical use cases is disaster prevention planning. The second product is AW3D enhanced. We work with US company, Mack, and we use their satellite imagery. It's the highest resolution among all commercial satellites in the world. AW3D enhanced is high resolution with high accuracy. The typical use cases are scientific analysis and, of course, civil engineering. And if you request it, we can offer contour lines along with them, and options such as road smoothing or water processing are also available for clients' specific needs for their projects. We offer ortho-rectified imagery as well. It's up to 30 centimeter resolution, and you can use it to visually confirm objects with latest imagery. Finally, we offer 3D building vector as well. It is polygon data as shown in the photo. It is used for simulations such as line of sight, sunshine, or wind. We can add texture to building polygons for visualization. But let me focus on digital surface models for comparison. This is visual comparison among 30 meter SRTM and the AW3D standard and the AW3D enhanced. On the left is SRTM, free data. In the center is AW3D standard. On the right is AW3D enhanced. Differences are obvious, and please take a look at AW3D enhanced. You can notice the sharp expression, and this is the most often used data for civil engineering. Here's the specification of AW3D enhanced. The resolution is up to 0.5 meter. The most important point here is the accuracy. It's 1 meter RMSE with ground control point and 2 meter without ground control point. RMSE is root mean square error, which is frequently used measure for accuracy. The accuracy of AW3D enhanced is equivalent to 1 to 2000 map scale. How could we achieve that level of accuracy using satellite imagery? The key technology behind that is multi-view photogrammetry. On the left show stereo photogrammetry, which has been traditional way to create 3D data from two-dimensional images. It uses two images from different angles from the same satellite and calculate height information for the target area. But we've applied multi-view photogrammetry. It uses more and sometimes tens of hundreds of images from different satellites from different angles to create 3D data and dramatically increase the accuracy. With the accuracy and the resolution of AW3D, we can help civil engineering projects in many ways. This slide shows the life cycle of civil engineering projects. Typically, you need higher resolution data, centimeter level, for example, for actual designing phase or construction phase. However, civil engineering project has long life. Sometimes it is more than 10 years. You need geodata phase by phase, and AW3D can help pre-construction phase best. Take preliminary design, for example. What you need is good enough level accuracy and resolution for wide area with low cost. For road designing and cost estimation, AW3D can be the best value for you. And AW3D and Softree's RoadEng will be perfect combination for your needs. Now imagine you can quickly get affordable geodata from home to maximize your project outcomes. That brings me to the end of my presentation. So let's design roads together. Thank you all for listening.
Thank you so much, Tepe, and thank you for getting up at the crack of dawn to join us. I am going to just kind of keep moving us along here. We've got next is Darryl Mack. He is the operations manager from Cambria Geosciences, Inc. And as I mentioned in my little introduction, Darryl represents a really unique perspective. He works with both AW3D Data and with RoadEng. And yeah, I'm going to invite Darryl to join us here. Make sure he's got his camera on. Hello, Darryl. Ah, I can see you, but I can't hear you.
Can you hear me now?
Yes, thank you so much for joining us today. So we're just gonna kind of kick off. Maybe we give us a little introduction to yourself and to the project that Cambria is working on.
Sure. So I'm a mechanical engineering technologist and a certified project management professional, but I specialize in spatial 3D data structures and remote sensing for mapping, modeling, and analysis. And at Cambria, really our forte is evaluating mineral exploration targets and properties using drilling, geological structural mapping, database systems, and 3D geological deposit modeling. So it's quite a combination of different data types that we use and different data channels. But primarily, one of the really important things that we have to have is accuracy. Roco is one of our clients. They're a publicly listed junior mining company. They hold the San Tomas copper porphyry deposit in Sinaloa, Mexico. We're retained as a project consultant, and we recently completed the surface mapping as well as a 3D IP geophysics campaign. At this point, the project is reaching, in the project timeline, the planning and permitting stage for a drilling campaign. And critical to that is a road design requirement, and that has to be approved by the various government parties in Mexico for environmental impacts and safety. And so that's the stage we're at now, is in providing that road design. So we're reaching this milestone in the project timeline when really COVID started to flourish and make a big impact on travel. And very quickly we realized we couldn't do our usual thing. Normally in road design and planning for these projects, we have people on the ground, on the project site, doing on-the-ground surveying, walking out the various road design proposal lines just to see exactly where we are on the ground. That was not possible. So at this point, the project timeline was really threatened. And so we realized we have to find a way to try and do this remotely and hopefully save the project planning and not get too far behind.
Nice.
Along
So
that
can
line,
you,
that's when we discovered AW3D's DTM data sets and RoadEngs, and they were a fantastic fit. AW3D, the high resolution 1 meter DTM that we use, it's readily available, it's cost effective, and I would say it sets the new standard for price performance compared to most other offerings in this space. They have a fantastic product. It's priced very competitively, and you get fantastic accuracy depending on the accuracy required. And as well, they offer the option of smaller areas. So you don't have to buy, there's the minimum requirement for the area coverage is very reasonable as well. So for the project, we required the DTM. And from that, I built a number of derivative products of contours along with terrain slope classification. And you can see there in the slide, across the river there on the north side of the river is a particularly steep area that we were doing the road design for. On the right-hand side of the slide, in color there, in green, orange, and white, is the slope classification, which, again, because of the high resolution, we're able to take these products directly into RoadEng, the ortho-rectified satellite imagery, along with this slope classification, so that I was able to really remotely see what was happening on the ground and do my road planning based on the slope percentage of the terrain. So basically, in the slide there in color, we determined that anything that wasn't really green to maybe yellow was okay. As soon as you get to the orange and white areas, those were no-go zones. They were just too steep. And we're finding now that we're getting feedback from people in the field that the designs work out very well. So as far as RoadEng goes, it's been a very good product. It's extremely user-friendly. I'd say cost-effective. Some of the other software solutions I was looking at, I could tell were going to be difficult to learn and implement. RoadEng had a very short learning curve. The team at the RoadEng office were fantastic. They provided great support. They were great to work.
so Darryl, I was supposed to ask you questions, but I think you just literally answered every question I was going to ask in your intro. Overall, though, how was the process of working with AW3D in RoadEng? From getting it, importing it, totally smooth?
Mm-hmm. Yeah, you know what? I work with a number of different software applications because I'm dealing with so many different types of data, and it can be a challenge bringing different data sets from one application to the other. There's typically conversions that might need to be done to go from a GeoTIFF to a grid format to some other format. Bringing the various products that I derived from the DTM, the AW3D DTM, and then importing those into RoadEng was absolutely no problem. So very quick and easy to bring them into the software. Setting up the project, what you'll see with Matt's demo is really not that difficult. For a brand new user, I was really surprised how quickly I was able to get to the point where I could actually start doing the road designs and produce the products that we needed for the permitting.
Nice, that's awesome. We are relatively tight on time, so I might just keep moving us along, but Darryl, please stick around for the questions here at the end of the webinar. And with that, I actually think we've got some of your data loaded up here in RoadEng, and I'm going to pass it over to Matt in a minute. But for those of you new to RoadEng, I'm going to give it like a 15-second primer. So that was Matt. He appeared and disappeared. Anyways, we are the makers of an easy-to-use civil design software. It is really focused around rural infrastructure projects. So that's working with large data sets, whether that's LiDAR, DEMs, AW3D data. That's kind of what our software is great for handling, and then long roads, and again, those rural projects. Some unique features really quickly: no CAD platform required. It is easy to use. Most of our users, like 90% of them, never have any formal training. Very much like Darryl, actually. I don't think he's ever had any formal training. We've got some real-time costing, earthwork optimization, and I am definitely not doing it justice. So I'm going to pass it over to my colleague, Matt. Matt, I'm going to turn my screen off here if you want to let yours.
Excellent. Well, thanks for the introduction.
And I'm going to turn my camera off so you guys can enjoy the software too.
Yeah, so thanks for the introduction. I'm going to turn my camera off here momentarily just because I'm going to be staring at another screen and no one wants to look at the side of my head. And we'll jump right into the software. So before I get clicking along, if you've watched a bunch or any of our other webinars, I'm probably going to talk a little less in this one than I normally do just for the sake of timeliness. And I won't go into a lot of detail or explanation on the steps I'm going in. Hopefully I'll at least mention the big ones that I'm doing, and yeah, just more give folks an overview of how the software behaves. If you've used the software a lot with the heavy data sets like LAS files or DEM, the functionality is really entirely the same, whether that DEM data comes from satellite or LiDAR or if it's coarse DEM. We just want to demonstrate how well we do work with it though. All right, so the software is modular, and we're going to start off in our terrain module. So we're going to use the terrain module to build the surface that we're going to design from, and then we'll jump over to the location module. So here, I'm going to start by clicking Insert File, and I'm going to bring in this area of interest shapefile. And I'm just doing that because I don't need the entire data set that we have in our DEM, and we're going to trim it down on import just so it's a little lighter to work with. So we'll bring in that DEM, and we're going to thin it based off the polygon that we've brought in. And that polygon could be anything. We could have drawn it in terrain or used a KMZ as well. So in the polygon, we keep all our points. Outside of the polygon, we're skipping all the points. So this will just take a moment to read in. And we'll see that magenta blob up here. So the points are in there. We've got just shy of 1 million points. And I'm going to grab some imagery off of the web. So we could absolutely bring in the high-res imagery from AW3D. In this case, we're just going to pull some from the web, just more for the sake of time than anything else. Don't have to go find another file. I can just grab that and download that. So this is getting pulled from the web, and it's going to be placed in a background. So we've got our image, we've already got our LiDAR data in there. Now we just want to take that LiDAR data and turn it into a surface. And while we turn it into a surface, we might as well create contours as well. So we're going to create a tin. We're going to set our contours to be 2-meter intervals and 10-meter intervals, and we'll hit OK, and we'll let this plug away. So this is going to, it'll take less than a minute, but it'll plug away, generate the contours. I'm going to kind of cheat a bit, and I'm going to go into the location module before this is done doing its thing. So in location, I'm going to click New File, and I'm going to browse, and I'm going to browse to a topo surface that I've already saved out of the terrain. So once that chimes, I'll try and remember to come back to it and just show the save, but if I don't, it's exactly what you'd expect. I hit File, Save. We've got that. So I just referenced the topo surface that we've created in terrain, and I'm going to start with a single point. And that chime, I don't know if you guys heard it, the contours are done, so we could just hit File, Save As, and then instead of referencing the file that I referenced, we could reference the file we just made. Now, in location, we can see our plan view. We can't see the background. I'm going to right-click Plan Options, click the background, and I'm going to reference that image that we've just downloaded. There we are. Also curious what our 3D looks like. So there we are. And I'm going to start designing my road. So I'm going to start by designing the horizontal. And this is where I'll probably get quieter than the normal. And I'm just clicking through. I'm keeping an eye on the different views. I'm going to try and avoid this really steep section that we can see from the contours. And I'm going to contour around, and we've got an area that we're trying to get to, and it's a fictional area. It's not actually a road Darryl's designing. Just a quick example. So my example, I'm going for that location. We'll click around. And so I'm clicking in the plan view, but I'm watching what's happening in my other views to make sure I'm not screaming down the hill too quickly. And I'm making little adjustments as needed. So there, right now, I've got that in. I don't have any curves. I'm going to add my curves. And to start, I'm going to go into my tighter corners, the switchbacks that I have here, and I'm going to apply a fairly tight radius. And I'll pull this around. I'm going to apply a tighter radius on my two switchback curves here. And we'll pull that down. And this is kind of one of the nice things, just how interactive everything is. So I can make changes, see how it changes in the subsequent views, and then we'll get into actually designing our vertical alignment as well. And getting close. So now I'm going to just fit my default curve to the remaining locations or the remaining IPs. That default curve is user definable. I've set mine at 35 meters per radius. We'll drag that up. So now I'm designing my vertical. And of course, it is all interactive. So there's no need to have a big fill on that location. I'm going to use 18% as my max grade for this. We can see our mass falls being updated in real time as we click through. And I can hover and see where I'm at in the different views. So I want to pull that out. And there we are. Running a little bit of a deficit. I'll steepen that up. Not bad. I'm going to add my vertical curves. I'll go with the K value for 3. And the last one. And we could absolutely go back through and make some tweaks and refine this a bit. But it is, that's a pretty quick design that's pretty decent, really. We're balanced. We don't have any big runaway cuts or fills. And we can use our design time costing function to recost our alignment and see what the expected costs are. So as designed, the earthworks here are expected to cost around $103,000. Now we can also do other things like add in culverts, produce output sheets. So our design package, if you're using it for IFC or permitting, or if you just wanted to produce a supporting document for your feasibility report. And we could add as many pipes in as we'd like as well. So that we can zoom in, see what our pipe's doing. Now, this is great. We can build on that. And I'm not going to go through all the steps, but we could click new horizontal alignment, duplicate that initial alignment that we've just clicked through, and do a quick comparison of route options. So here I've got that one in there. I can compare alignment similar to the one that I just did versus another one where we come off the existing road, which we can see a bit in the 3D here. And one's a cost of $125,000 versus $121,000. So pretty user-friendly, pretty quick. Yeah, and as has been said a few times before, the two products complement each other quite well.
Awesome. Well, thank you so much, Matt. I'm just going to get my little webcam showing here again. Yeah, so this is the time in the webinar. I apologize, it wouldn't be a Softree webinar if we were on time. So we're 7 minutes over, but we've got a bunch of questions here. Please, if you're watching, you've got a question, you're curious, type it into that Q&A section, and I'll get all of our presenters, if they can, just to get their cameras showing. And yeah, let's tackle some questions. Okay. I got a nice little list here. So starting at the top, what is the minimum order size for AW3D data? So Tepe, over to you.
Okay, thank you for the question. To be honest, it's one of our advantages. The minimum order size of the AW3D enhanced is 25 square kilometers. If you compare it with similar vendors, it's quite small. And that way, we differentiate ourselves from others, trying to meet our important clients' needs. So these clients tend to repeat orders, and we can deliver and maximize our value to the market in the end. So our most important value is long-term relationship with our clients and partners. That's what we value the most.
Excellent.
That's
okay.
My point.
So yes, 25 square kilometers. That's awesome. It's actually small. And then while we're doing it, I'm going to tackle another question very much related to that here on the list for you. What's the delivery timing on it? How long would it take to deliver the data?
So that's a question to me. Yeah.
Yes, again to you. Sorry.
Sorry. So it takes 2 weeks, around 2 weeks, but it depends on the size of the area, of course. And but the standard timeline is from 2 weeks to 3 weeks.
Awesome. Okay, I'm trying to figure out this list and see if I can group some questions that are similar. What kind of definition can one get of a road prism at the different resolutions offered? So I feel like that could be a Matt question. Definition of the road prism, or are we talking Tepe here? Oh.
I think it's probably related to the 3D, and I think that would probably just depend on the resolution and also the condition of the road. If it's a road that has just a path that has had the ditch infill and the outside slope slough away, it's going to be harder to see it. And this is a pretty rough road here, but we can kind of make it out with our 1 meter spacing. I would suspect it's that much better with the half a meter spacing.
Okay, next question. Actually, Darryl, I think this one's for you. Why did you select AW3D over other DTM and DEM products?
Yeah, I think the two determining factors were the price point and performance. In the junior mining space, they tend to have limited budgets. These are not all big companies. You know, Heroku is a fantastic company, doing very well. But some of our other clients are on very limited budgets, and they want to pay for just the data they need. They don't want to pay for a large 100 square meter area if that's not not the size of, beyond the size of the property. So Tepe's point on the size of the data delivery that they offer is pretty exceptional in this space, and then the price performance, so the high resolution and the cost of it is really leading the sector, I think.
Awesome. Okay, moving along. I think we'll probably, oh my goodness, they keep coming in. Okay, so this is the question. I'm going to answer this one. How soon will the recorded video be available for viewing? I'm going to say 4 hours. Depends on the download time and then the upload time and how fast somebody at Softree can handle it, but it will be up on our YouTube channel. So if you missed something, want to go back, especially look at that spec sheet that Tepe had up on some of the different products, you can get that. It will be on our YouTube channel. And as anyone who attended this, you should be getting an e-blast that tells you yeah, what that link is specifically. Okay, next question. Can I customize my cross-section? I think, Matt, if you want to tackle that one.
Okay, am I still sharing my screen? I think
you
so.
You are still sharing your screen.
Excellent. So yeah, you may have noticed I jumped in just making, using some default settings for this. My default road or turning radius was set at 35. So that was also set in my templates. So templates are going to be mostly used for setting up your cross section. I used my default, which was set up as a 6 meter running surface width, so 3 meters either side, and a ditch and whatnot. Yeah, we've done our own webinars solely on cross sections. They're pretty flexible. Yeah, and you can really get them to do whatever you like. So you're not stuck with any one cross section geometry.
And I think we actually have a cross-section webinar coming up in a couple weeks.
Oh,
I should know this. Cool. Okay, sorry, we're going to just keep chugging along here. If anyone needs to leave, thank you so much for joining us. I know we're over time, but we're going to keep answering questions for another few minutes. This question is for Tepe. It says, I missed a couple minutes at the beginning of the webinar. What was the horizontal and vertical accuracy? Do you mind repeating it? And you are muted.
Sorry again. Yeah, it's a 1 meter RMSE with ground control point and 2 meter without ground control point. That's our basic specification for AW3D enhanced.
Awesome. The next question, does RoadEng work with vectorized data? Matt, you're actually that way on my screen.
So I'm not sure if I completely understand that question, but for vectorized data, if you're talking about like your typical vector formats such as shapefile, KMZ, or really anything that you make a line out of, absolutely. So our own formats being for location DSNX and terrain TRX, they all do well at ingesting those other software formats.
And then the question asker, I think they've just clarified a little bit. They said vectorizer meaning break line strings.
Oh, yes, absolutely. So I don't have an example set up here, but that's something we do quite well. So we introduced it as we deal well with the large data sets. We also deal well with the really small data sets. If you've got a site plan from a total station survey or something like that, we can ingest it really easily and format how your different break lines behave, or different lines that you don't want to behave as break lines when they come in. So the short answer is yes.
Awesome. Next question, where do the costs come from, and can I update them with my own?
Yeah.
Again, so sorry to Matt.
Yeah, that one's me. Yeah, so again, another thing that I used with the default values. So in this, I've used one ground type for the entire length of our road. So we can break up using different ground types along the length of our road by chainage, and we can use different horizons for those materials and define them in here. So in our ground types table, we can define different geotechnical parameters for those, and each ground type we can also define cost parameters for them. So here I've got my overburden assigned, and I've got a unit cost for excavation, $12 a cubic meter, placement compaction, $4 a cubic meter, and then for our material movement, we have broken down into our haul cost. Yeah, so we can set this up to categorize your material movements, and that's all accounted for in there. Material movement is shared amongst all materials, and the handling costs can be unique for each material. So if we went to solid rock, it's obviously going to cost more. And you can add as many of these as you'd like, and you can save it for future use. So if you want to see something that you've customized when you open up the software, just save over your normal, and then that'll be the ground type, that ground type file that is read in.
Awesome. Okay, moving along. Darryl, after COVID's done, do you still plan to work with the satellite DEM data from AW3D?
Yes, we're actually going to continue in this manner. It's still made great to have people in the field that can get on the ground, but we can do a lot more before that happens now by taking the data from AW3D and do some preliminary planning. And in this case, really, we've been able to take it from planning all the way to a permitting application without really having to do too much on the ground whatsoever. So it's been a great product that way. The other thing we're looking at doing is there's a lot of geological exploration. We call it remote exploring. So we can take the AW3D data in places where there's bedrock exposure. Because of the high resolution, we'd actually be able to see some of the structural, visible structural attributes that are on the ground where there's no vegetation or coverage there. So we can actually use that data, use the AW3D for more things than just road design.
That's awesome. Okay. My goodness, there's so many. Guys, stop asking questions. I can't handle it. Good prop to have though. Will RoadEng handle complex spirals? So we're talking curve, spiral, curve. Matt.
Yep. Yeah, so in here, in our curves panel, I've just used our simple curves. So if I turn simple curves off, and it's going to take a moment to think about things, my curve panel is going to change. And then instead of just having circular curves as an option, we'll see spiral curves are also an option. And there, so we've got spiral curves down there. So we can absolutely add the spiral curves if you're doing rail or highway design.
Cool. This one is for Tepe. How does AW3D, sorry, make sure I read this correctly. How does AW3D process satellite imagery to avoid vegetation? Yeah, that's essentially the question.
I think it's quite technically detailed. So we use our algorithm. So we use artificial intelligence to remove those data. But anyway, if you want to know more detail, you can contact me, and we can discuss about it.
Okay, excellent. And then I think we've got a few more, and I might just connect this user to, they're looking to understand what website they can order from, and I will put that up here at the end of the webinar. Another question for you though, how long does it take to get a sample ordered through your website?
Sorry, can you repeat that?
Yes, yeah, I think how long does it take to get a sample ordered through your website?
It doesn't take too long. I think if you ask, it takes basically 1 week or so.
Excellent. And then the next question here, it is for Matt. No, it's not. Yes, it is. Sure, I'll skip that. I was reading out of order. I apologize. Does RoadEng support NAD83, CSRS, or just NAD83? So we're talking
Projections.
Yeah, projections.
I should know what the CRS is yet. I believe so, and have to check, but in our projections, so in the drop downs, so I've got UTM, we'll go NAD83, and we've got drop downs for a few options for datum. We can get around what we have access to just for the drop down options by clicking the plus, and we can either add in our own projection data in WKT format. So if you're working with a lot of shapefiles or anything with a world file, a shapefile will contain the projection. You should just be able to open that up in Notepad and paste that in here. And then alternatively, if you happen to know the EPSG code for the full projection you're using, you can just search it by EPSG number.
Awesome. Darryl, what vertical accuracy have you found horizontally and vertically?
Yeah, going back to Cato's technical specification with root mean square error, it is exactly as to the specification that they promote on their website, and yeah, it's proven to be very close, really exactly what they said. So we've been very happy with that. I'm actually going to add on just to Matt's last question. I hadn't realized that custom projections could be put into RoadEng until he just showed me that. And in the junior mining space, that's actually quite important because a lot of the mining sites and historical mining and explorations occurred. Quite often, it's done in its own custom mine grid projection.
Mine grid, yeah. Yep.
That's good to know that.
You can account for it. It's yeah. If it's a custom mine grid, you'd have to come up with the WKT format for it. But if it's on hand, easy peasy.
And then all the vector data, because in the mining exploration space, quite often these properties have 10, 15, 20, 50 years of exploration work on them. And there's a large variety of vector data, historical drug collars, old roads, and all of that imports into RoadEng. So, and we did some of that on the Santos project.
Awesome. Okay, guys, I think I'm going to shut the questions down there. So to the people who still have one in the list, we will follow up with you directly and we'll get you an answer. We do have the emails that come in with the questions. So we will handle that. And then the one other question I said I would show here at the end, hopefully it's showing, just the websites. If you do want to get in contact with Softree, softree.com, then we've got the QR code, which is so cute, for AW3D. And then as well, if you want to get in touch with Cambria Geosciences, the best way to do it is either actually coming through us through Softree, and we're happy to put you in contact with Darryl, or you can go up to their LinkedIn. But to everyone here, thank you for taking an extra 23 minutes with us over time. We enjoyed having you. Kind of fun to show our cameras for once. I know Softree, we're kind of just like screens. We show the software, we do our technical stuff, but it's kind of fun to put a face to a voice. As well as to have some awesome partners. So Darryl, thank you so much for coming, adding this great user perspective today. I think it's really valuable. And then Tepe and team, thank you for your participation. We're pretty excited to continue to work with you guys more and work with your data, and look forward to it. So thanks everyone. Stay tuned for a follow-up email with a link to the video. You can share it, you can like it in YouTube because we love those, and have an awesome rest of your day.
Thanks, everybody.
Thanks, everyone.
Yeah.
Thank you, everyone. Bye.